Hello, I'm David Riley, and this is a single-point injected Rover 820. It's a beautiful, technically advanced car. But if anything goes wrong, how do you diagnose faults? Now, we all know the importance of correct fault diagnosis on any car, but how do we achieve this? What you need is the right information, and that's what this program is all about. We're going to show you some common mistakes and how to avoid them, plus hints and tips on 4 of the problems you may encounter. Now, to gain an insight into the system and how it operates, watch this video on single-point injection. It's good background material. Throughout this program, we'll be using diagnostic equipment from the Fast Check range, because it requires a more detailed procedure. But for those of you with COBEST, it's even easier. This booklet accompanies the program and contains a step-by-step guide to diagnosis and cure of all the 12 symptoms. It also contains a new style fault diagnosis chart. Each check is numbered in the left-hand column and the test equipment required is alongside. To use this chart, just find the symptom that relates to the customer's problem you've identified and complete the checks in the given sequence until the fault's cured. All this information is also in Rover 800 Technical Bulletin number 7, item 20. This approach relies on you obtaining an accurate description of the running problem. The way a customer describes a fault may be completely different to how you would describe it. So, when necessary, carry out a short road test in the presence of the customer. This avoids confusion and shows the customer you're taking his complaint seriously. That's the theory, but how does it work in practice? Now that's what I call erratic. In this case, the technician has confirmed that the engine speed dips on return to idle and almost stalls. So, what's the cure? Well, our technician has concluded this is simply a case of adjusting the idle speed. Wrong. Taking that approach and diving in with a spanner on this system makes the problem worse, not better. Don't jump in and adjust idle speed. As with any vehicle, make sure the fault isn't caused by something as simple as a loose connector or vacuum pipe. Carry out some preliminary checks. The vacuum pipes may have been incorrectly routed, or certain areas of the intake ducting may be damaged or displaced. Once you're happy the system is intact, you can begin. Cue the fault diagnosis chart. The symptom is idle speed erratic, and in this case, the engine dips on return to idle. The first step in the sequence is to check CO content using an exhaust gas analyzer with the car at normal operating temperature. This is because if the mixture is wrong, the engine will need a wider throttle opening to keep it running at its controlled idle speed. In other words, the system is working overtime, trying to control an uneven idle speed. It's particularly important to warm automatic vehicles with a short road test. Warming them up in the workshop won't heat the transmission oil fully, and you'll get false readings. When you return from the road test, connect a tachometer and use a warmed-up, calibrated infrared CO meter to check exhaust content. Make sure all electrical loads on the car are switched off. If the cooling fan operates whilst tuning, wait until it stops. Then raise engine speed for 10 seconds and carry on. It's important loads are not applied during the tuning process because the additional alternator loading will affect CO readings. The mixture is slightly out of adjustment and this will need correcting. Lift the airbox just enough to gain access to the throttle linkage, taking care not to damage the intake trunking or the temperature sensor harness. Also make sure the vacuum pipes do not become disconnected. At this point, just check there's clearance at the lost motion link. And if it's an automatic, make sure the kick-down cable's not acting as a throttle stop. Temporarily replace the airbox and connect the serial diagnosis fast check to the diagnostic lead, and then to the battery. Turn the ignition on and press start. The fast check shows the type of ECU fitted, 33 for manual, 34 for automatic. With the vehicle at normal operating temperature, start the engine. Wait 15 seconds for the engine speed to stabilise. If you don't allow the idle to settle down, the fast check won't carry out the test and the 00 code will appear. Why is this? What's happening inside the ECU to cause the 00 code?
This is command center. Unstable idle speed input. Coolant temperature and engine speed inputs are abnormal. Instigating corrective measures on injector duration. Input from idle is still unstable, attempting correction. Input from fast check cannot be accepted at present. Situation here needs immediate attention. Instigate 00 code and attempt reconnection later.
So you can see, if the ECU is trying to control a wildly unstable idle speed, it won't talk to the fast check and the 00 appears. You may still get 00 even after waiting 15 seconds. If this is the case, check for blocked hoses and temporarily set base idle. This will stabilise the idle speed and allow the fast check to carry out its tests. If the cooling fan operates as you're about to use the fast check, wait for it to finish before pressing start. If there are no faults on the system, the test complete and adjust CO lights will illuminate. Adjust the CO with the plus and minus buttons. Allow the idle speed to stabilise again, then press Set CO. Wait for the correct response. CO set and 88. And remove the equipment. With the CO set correctly, you can get down to the most probable cause of idle speed dipping, and that's the base idle speed. Base idle is used by the ECU to determine engine idle speed at startup and engine speed when returning to idle. Remember, always set CO first, as CO content will influence base idle speed. Now to adjust the base idle speed. With the ignition off, peel back the rubber boot on the stepper motor connector so you won't damage the pins pulling it apart. Connect the stepper motor fast check using the single point lead and fully retract the stepper motor pin until you hear it ratchet. Start the engine and check base idle. This one is very low. We found the problem. Adjust to the correct figure in the repair manual, remembering there are different settings for automatic and manual cars. When base idle is correct, set the throttle linkage lost motion gap before you reconnect the stepper motor. Always confirm the problem has been solved with a road test. By following the checks listed in the fault diagnosis chart, you'll quickly find the fault. It's just a matter of going through the tests in numbered order until it's cured. In solving the problem of an erratic idle speed that dips, surges or stalls, let's recap exactly what was done. He checked for air leaks and bad connections. Checked vacuum pipes and air intake ducting. checked idle CO setting, and using a serial diagnosis fast check, set the mixture. After using the stepper motor fast check, he set the base idle. Then finally, he set the lost motion gap. Yes, hesitation on initial drive-off can cause your customers problems. Now, the technician has found an initial hesitation or flat spot. During the road test, he was coasting gently in a traffic queue without pressure on the throttle. But when the throttle was pressed lightly, the engine faltered. This technician has worked on injection systems before. The fault is apparent on acceleration, so he immediately assumes the engine isn't receiving the correct amount of acceleration enrichment. He comes to the conclusion it must be a throttle potentiometer fault. Fair conclusion? Wrong. So, where did he go wrong? He gained all the information about the fault. That was okay. But then he tried to apply rules learnt on another system to this one. From then on, it was all downhill. Cue for the new fault diagnosis chart. The symptom is hesitation on initial drive-away, and the first check to make is the throttle linkage lost motion clearance. Why? Well, it all boils down to this system operating in a different way to those you're used to. The fuel ECU has two programs, one for idle and one for all other conditions. A throttle switch on the accelerator pedal is used to tell the ECU when to select the correct fuel map. When the lost motion gap is too great, the throttle switch contacts will open, telling the ECU to select the main fuel map too early, before the throttle disc has opened. This makes the fueling very weak, causing the flat spot. To set the lost motion gap correctly, the throttle disc must first be indexed to its base idle position. As we did before, remove the airbox just enough to gain access to the stepper motor and retract the stepper motor pin with the fast check. Now the vital part. Check the lost motion gap with the figure in the repair manual and adjust if necessary by changing the throttle cable outer length. Reconnect the stepper motor and replace the airbox. Now road test the vehicle. If the fault's still there, carry on through the checks. In 90% of cases, correct setting of the lost motion gap will cure hesitation or flat spot on initial throttle take-up. But what if you're one of the unlucky 10%? Let's take another look at the test sequence. The next checks for hesitation or flat spot involve using the serial diagnosis fast check, which apart from allowing you to set CO, also performs preliminary circuit checks without having to disconnect the ECU. The next test on the chart involves using the system diagnosis fast check to test individual circuit inputs, outputs, and the ECU itself. In this case, the throttle switch has stuck closed, causing a flat spot, because the main fuel map won't be selected until the engine reaches 1500 revs per minute. To check if the throttle switch is stuck closed, use the System Diagnosis Fast Check. On the correct test, when you press the accelerator, the switch should open and bring the red light on. If the green light stays on, the throttle switch is stuck closed. An important point is that whenever you connect the System Diagnosis Fast Check, you always lose your CO settings and need to reset them using the Serial Diagnosis Fast Check. So to recap, checking for hesitation or flat spot. First, we checked the lost motion gap. Using the Serial Diagnosis Fast Check, we did a preliminary test on the circuit. The System Diagnosis Fast Check was used to check the throttle switch. And you then need to use the Serial Diagnosis Fast Check to reset the idle mixture. Now, what if your customer complains of lack of pulling power, especially with light acceleration at about 60 miles an hour? You may think, with that kind of symptom, it could be a weak mixture, a faulty ignition system, or maybe a throttle potentiometer problem. In fact, they would all be wrong. Cue the fault diagnosis chart. The symptom is poor performance mid-range. The first check is to make sure the car has the correct airbox fitted. The new type has a small pip or a dab of silver paint between the two bottom holes. This one hasn't, so it'll need changing. When refitting the airbox, make sure the tabs locate around the injector. If they don't, they'll bend as the box is tightened down. The next check in the sequence is full throttle capability. Check the throttle disc is fully open with the pedal fully down. The next step is to check kick-down cable setting on automatic vehicles. So to summarise, if the problem is poor mid-range or top-end performance, the first check is to see if the new type airbox is fitted, and replace if necessary. Check the throttle disc opens fully when the pedal is pressed to the floor. Then, if it's an automatic, check the kick-down cable setting. Continue along the check sequence if the fault persists. Poor cold drivability. With our climate, it's a problem that can affect vehicles all the year round. Surely this one must be a clear-cut case. If the engine runs okay when it's hot and badly when it's cold, it's simply a case of the engine not receiving the level of fuel enrichment it needs. Yes? No. Wrong again. Use the chart. The symptom is poor cold drivability. The first check to make is the thermac control system and the hotbox pipe. This controls intake air temperature to a constant 30 degrees Celsius. So, anything that stops the system from working will cause the cold drivability problem. There's an easy way to check the thermac control system. First, make sure the exhaust manifold is cold. Start the engine and pull the pipe from the distribution flap. The flap should be heard to snap shut. And vacuum should be felt at the pipe. Next, reconnect the vacuum pipe and warm the engine to normal operating temperature. Again, pull the vacuum pipe from the flap. No sound should be heard from the flap, and you shouldn't feel any vacuum. If the system fails this test, Check the vacuum pipe connections. Looking at the underside of the Thermac valve, the pipe connection with the small hole goes to the manifold, and the one with the large hole goes to the distribution flap. If these pipes are routed wrongly, the system won't work and will cause poor cold drivability and instability at idle. There are a few more faults that will cause cold air to be drawn into the engine. These are if the flexible hose between the exhaust manifold and the distribution flap has broken or is disconnected, or if the flap housing has become detached. Also check that the duct from the air filter to the air box hasn't collapsed and is letting in cold air. If the intake temperature control system is working and the pipework is sound, the next check is for PTC manifold heater operation. This heater only operates below 55 degrees centigrade, so make sure the engine's cold. Then pull off the oil pressure switch lead and turn the ignition on. If it's working, the base of the heater will feel hotter than the surrounding manifold. With later vehicles that have a yellow relay mounted on the left-hand suspension tower, it's not necessary to pull off the oil pressure switch lead. Just switch the ignition on. So to recap on what to do if the problem is poor drivability with a cold engine. First, the Thermac valve with a cold and hot engine. Then the vacuum pipe connections, the flexible hose and airbox ducting, and the PTC heater. Continue the check sequence on the fault diagnosis chart if you still haven't found the cure. OK, we've gone through 4 different customer complaints explaining how to use the fault diagnosis chart, and to round up, here's a quick recap of the most important points to remember. Always gain as much information on the nature of the fault as possible. Perform a road test in the presence of the owner where necessary. It gives you the opportunity to do some valuable PR work. Warm the car to normal operating temperature on a road test. A static warm-up will give false readings. Ensure no electrical loads are applied during the tuning process. This includes the cooling fan. Always set the throttle linkage lost motion gap while the throttle disc is at its base idle position. Set CO content using the Serial Diagnosis Fast Check or COBEST. Base idle speed can only be checked with the engine fully warm and the stepper motor pin fully retracted. And finally, on automatic vehicles, make sure the kickdown cable is correctly adjusted. If you remember these basic fundamentals, you won't go far wrong. The single-point injection engine management system is different to other injection systems, and you must avoid jumping to the wrong conclusions. The system caters for every possible driving condition, but to do this, it relies on the accuracy of its initial settings. Fault diagnosis is a bit like going through the Hampton Court maze. If you know the right path to follow, it's easy. But if you take the wrong turn or make the wrong decision, it can mean a lot of time and frustration before you find your way through. So use the information available to you in the booklet to help you through the maze of fault diagnosis and save yourself time and frustration.